Here's a problem dealing with parallel lines. It wants us to prove that A and B are parallel, and at the same time line segment C and line segment D are parallel. And it gives us a couple angles here. 1, 2, 3, 4, 5, and then it gave us a 6 right there. So let's go through here and see. This shouldn't be too difficult, but the problem is you sometimes get confused with, oh, does that prove these lines are parallel, or is it these that we're talking about being parallel? So let's go through and take a look. It says angle 1 is equal to angle 6. So right here you would have angle 1 and 6 equaling. Now notice angle 1 corresponds to 4, and 4 is the vertical angle to 6. So these, which are called, in this case they're called alternate, because they're on the alternating sides of the transversal, exterior angles. And if your alternate and exteriors are equal, then you've proven that the two lines the transversal is going through, in this case C and D, are parallel. So 1 equaling 6 will prove that C is parallel to D. So that takes care of one piece. What I'm going to do is I'm going to write above it, or I'll do below it, this proves C is parallel to D. Now let's see what 3 equal to 5 proves. 3 equal to 5, well those are corresponding angles. That proves this line and this line are parallel. It proves C's parallel to D. Well, we already proved that. So really it's not proving that A is parallel to B and C is parallel to D. That's just proving C is parallel to D 2 different times. So that is not what we want. Let's come to the next one. 1 equal to 6. Well, we already showed that that proved C was parallel to D because they were alternate exterior angles. There's the transversal, alternating sides of the transversal on the exterior of the two parallel lines. So that gets C and D parallel. Now it says 4 and 5 are supplementary. Now this is making a comparison from here, this line to this line, using this as a transversal. That would maybe help me prove something about A and B. Well, let's see if that something, though, does prove they're parallel. I know 4 would be the same as this angle right here. But if 4 is right there, that and that do have to be supplementary. They're a linear pair. So since 4 matches this angle, and that angle and 5 are supplementary, that means 4 and 5 are supplementary. That does prove, in this case, since we're going from here to here, this being our transversal, it proves A is parallel to B. This is the one we want. But let's go through and double check that maybe they have one of these options where they want us to check every box that proves it. Let's make sure about C and check D. It says 1 is equal to 4. Well, those are corresponding. That will prove, since this is a transversal, it'll prove 1 and 4. That'll prove C's parallel to D. What about 1 and 2 are supplementary? Those aren't supplementary. Well, yeah, they are. Excuse me, they are supplementary. They do add up. They're a linear pair. They add up to 180 degrees. So that is true, but that doesn't prove anything about things being parallel. So this doesn't prove anything. So it doesn't do us any good. Just because those are supplementary, that and that are supplementary, that and that are supplementary. 4 in this piece are supplementary. That doesn't prove anything as far as parallelism goes. So let's get that guy's out of the picture. Let's go to D. Angle 1 and angle 3 are supplementary. 1 and 3. Now again, we've done this before. 1 would be the same as right here. 1 and 3 would be a linear pair, so they would be. So that will prove, since these are corresponding, that will help us prove, this being the transversal, that A and B are parallel. That proves A is parallel to B. What about 1 equaling 6? Well, 1 does equal 6. Does it? I don't know. Let's see. 1 comes down here to equal 4, and 4 is the same as 6 because they're vertical angles. So that ends up helping me know that they're equal to one another, but it doesn't say they're equal to one another. It says they're supplementary. They add up to 180. That's what it says right there. 1 is equal to 4 and 4 is equal to 6. If it had said 1 is equal to 6, it would have helped me prove that C and D were parallel, but it doesn't. It says they're supplementary. They're not supplementary. They're equal to one another. So that's a false statement there, which rules out D. So our choice here is choice B that helps us prove A and B are parallel and C and D are parallel.